In this video, I discuss recalibrating chemoreceptors, the control centers of respiration. Okay, so the chemoreceptors, they're located deep in the brainstem, in the medulla and the pons, and they are like a thermostat in a house. They are measuring changes in the amount of carbon dioxide or oxygen in the bloodstream, and then they're sending signals to the muscles, to all of the muscles of respiration to increase or decrease the speed of breathing, to increase or decrease the volume of breathing. So the chemoreceptors, just like a home heating system, which has a thermostat, the thermostat can become faulty. The chemoreceptors can also become faulty. They become oversensitized. They have less tolerance to carbon dioxide, and they prematurely trigger a hyperventilation response. That gets rid of too much carbon dioxide unnecessarily, and that decreases the efficiency of breathing. So at any point, whether we are active or at rest, we want to have the optimal amount of carbon dioxide in the bloodstream, because that will make our breathing more functional, less effortful, more calm, more restorative. And when we're active, we want the chemoreceptors to measure that there's a buildup of carbon dioxide in the bloodstream, and to increase the speed, the cadence, and the depth of respiration so we can exhaust carbon dioxide. But we always want to have the optimal biochemistry, the optimal amount of oxygen and carbon dioxide in the bloodstream. And that changes dependent on each situation. So the chemoreceptors, they're part of the brain and nervous system, and they're plastic in nature, so neuroplasticity. They change through experience. So if we expose if we've become intolerant of carbon dioxide, then what we need to do is sort of create these momentary states in the body where we increase the level of carbon dioxide. Maybe we can do that for a sustained period through a breath hold. We hold our breath for 20 or 30 seconds. The CO2 level begins to build. We keep that, and this forces adaptations to the chemoreceptors, to these structures in the brain, because they're neuroplastic in nature. We force these adaptations to recalibrate, to make them tolerant, or to optimize their level of sensitivity to carbon dioxide. And we have an exercise called the control pause exercise, which helps us to track if we're our level of tolerance to carbon dioxide, and that helps us to understand whether the chemoreceptors are hypersensitive or not, whether they're faulty or not. And we have a selection of breathing exercises that create these momentary state changes within the body that then create long-term trait changes by forcing adaptations to the nervous system, to the chemoreceptors. Okay, so the chemoreceptors located in the medulla and the pons of the brainstem control rate and depth of respiration, send signals to muscles of respiration to adjust breathing based on oxygen needs. Chemoreceptors, they do this by detecting changes in blood pH. So acidity, this is a proxy for carbon dioxide. So they measure the acidity of the blood. Remember, carbon dioxide is an acid. Oxygen is alkaline, so it's measuring acidity, and that's what controls and then it sends signals to the muscles of respiration to change the tempo, the depth of breathing, so that it can return the acidity to its optimal level, and this supports sort of that homeostasis and balance. But sometimes this system becomes faulty. It increases respiration to expel carbon dioxide if the blood becomes too acidic, and it's like a thermostat in a home. The importance of this recalibration is that dysfunctional breathing patterns can oversensitize the chemoreceptors, and this program's breathing exercise aim to recalibrate chemoreceptors to increase carbon dioxide tolerance and optimize the biochemistry of breathing. So this teaching about chemoreceptors coupled with this teaching of Bohr effect is very important. And it's also, we start in later videos, we're going to look at why the chemoreceptors have become hypersensitive, why they have become faulty, what dysfunctional processes have become established that mean that the chemoreceptors prematurely trigger a hyperventilation response. So we start to see all of these pieces coming together, and we have ways of measuring the level of tolerance, and we have practices that can begin to increase our tolerance to carbon dioxide and optimize and recalibrate the chemoreceptors. Okay.